This video is about human population part 2. We're going to start by talking about the demographic transition. So the demographic transition is actually a model which explains how human populations change as they move from a pre-industrial to a post-industrial society. And it considers economic effects and also cultural changes. There are 4 stages to this demographic transition. The first stage is called the pre-industrial phase. And so we can see over here on the x-axis, even though it does not show it, we're looking at time. So imagine this is 0. On the y-axis, we're looking at growth rate. So what's happening during this period in a country is that there is little or no industrial base. And so most people rely on agriculture for food and for income. There's generally very poor sanitation and little access to medicine. If we look at the graph, you'll see the birth rates, which are shown by the red line. The birth rates, which are shown by the green line. So this is birth rate, green line, are relatively high. Now, when I say high, I mean if you realize down here at the bottom, that's low, and we're all the way up here. So birth rates are high. In addition, death rates, which are red, shown by the red line, they're also pretty high. Even though they kind of go up and down, they're still high relative to the bottom of the graph. And so population growth at this point is very slow. And it's very slow because the birth and death rates are kind of matched. So people are dying as quickly as they're being born, for the most part. There's a little bit of growth. The second stage is called the transitional stage. What's happening here is that there is more industry and better economic conditions. That means people have more food, they have better medical care, better sanitation, and technology has come along, which brings a lot of benefits with it in itself. If we look at the curve again, we'll see we passed through the pre-industrial stage where birth rate was high, but so was the death rate. And now we're in the transitional stage where the birth rates are still pretty high, but the death rates are starting to go down. Okay, so the birth rates are still pretty high, but the death rate is going down. And so the population growth at this point, oops, I'm sorry, I did that incorrectly. Let's say this again. So the birth rates are high, the death rates are low, but the population growth now is increasing rapidly. And it's increasing rapidly here because you can see that the difference between people dying and people being born is greater. So not a lot of people are dying and a lot of people are being born. So that's going to increase the growth rate fairly rapidly. Now, the third stage of the demographic transition is called the industrial phase. So at this point, industry is well established. There's new employment opportunities now, especially for women. And if we look at this stage here, you'll see that the birth rate's starting to go down. And that might be because women are starting to get into the workforce and they're having less children. And more importantly, they have access to birth control. So birth rates are fairly low, or they're going down, and death rates are still going down here. So at this point, the difference between people being born and people dying is getting less. And so the population growth rate is starting to slow down as you see the difference between births and deaths get closer together. The last stage is called the post-industrial stage, so we're over here. And now you can see that the birth rates are low and the death rates are low. So at this point, population growth is stabilized. because you have equal numbers of birth and death, or sometimes it is even decreasing slowly because the birth rates might be actually below the death rates. So this is a demographic transition, and this is based on data collected from many countries that seem to have followed the same process. If we overlay now the rate of population growth, which you can see in the green here, so here's the rate of population growth, okay? So if we overlay that on the demographic transition, we start to see some interesting things. So again, here's the pre-industrial stage right here. And birth and death rates are both pretty high, right? They're high up on the curve here. So the population really doesn't grow that much. And if it does grow, the growth is very slow. So you can see the green line here is growth. Then we get into the transitional stage. Here they're calling it the industrializing stage. And you'll notice that the death rate begins to fall because life becomes better medication, more benefits, more food. And the birth rate is still fairly high. It's beginning to fall a little bit, but there's a big difference here between birth and death rates. So now you start to see the growth rate, the population growth rate rise up. In the next stage, which we call the industrial stage, they call the mature industrial stage, the birth rate is falling and the death rates are falling. But you still have a big difference between the two, death and birth rate. So here you're still seeing the population growth rate go up. This is in the industrial, but it's slowing down. And then finally in the post-industrial phase, the birth and the death rates are low again. And they're very close to each other. So the growth pretty much levels off here. It might go up a little bit, but it usually levels off. So as a country's economy changes from this pre-industrial to this post-industrial, but the birth rates and the death rates drop, and the population stabilizes it, and it can even decrease. And this is really the stage 4, this post-industrial, is really where a lot of European countries are now. So the question is the demographic transition a universal process? Does it happen everywhere? Well, it's occurred in many European countries. They fit this graph, their growth rates. The U.S. this happened in the U.S., in Canada, Japan, and several other developed nations over the past 200 to 300 years. In fact, China's decrease in its total fertility rate, remember this is the average amount of children that each woman has, appears to be due to a demographic transition rather than the one-child family policy. In other words, instead of the drop in the total fertility rate being due to that one-child, one-family policy, it coincides better with the biggest gains that China made in its economy, which really fit better with the demographic transition. In fact, many countries have had a decreased total fertility rate without having population control plans, such as Japan, Singapore, and Thailand. What do you think? What do you think about this demographic transition? Is it a universal process, and has it fit every country? Well, so far it kind of looks that way. Now, one thing to keep in mind is that just because the growth rates are falling does not mean there's going to be fewer people. So let's take a look at this graph, and you can see here on the x-axis we've got the years, and we have two y-axes. We've got one here, y1, which is the average annual rate of change, percent. So you can think of this as the average rate of increase in the population. Y2 is the global population in billions of people. And this is shown by these bars that are kind of, they're kind of faded here. You can see the bars. So if we look at the lines first, and you can see the orange is the least developed countries, then red is less developed, blue is the world, and the green is the more developed. So according to this, it certainly looks like the greatest decrease in the rate of growth is in the more developed countries, the green ones. And the least decrease in the rate of increase of growth is in the least developed countries, and so on. So, but no matter what you're looking at, you can see that the population growth, the world population, it's still going up. So even though the growth rates of each country is going down, the world's population is still going up. And the reason for this is because there are still many developing countries that have this large base of young people in their population. And those young people are going to reproduce and have more children, and that's going to cause an increase. It's just that the increase is not going to be at a great rate as it would have been. So again, the world population rate is down, the growth rate is down, the growth rate, but the population is still increasing. So remember, a rate is basically numbers of people per year, or miles per hour. So it's per something, whereas the total number, which is what we're looking at here, is not a rate. So you can see here the light blue line is showing you the world growth population rate. And you can see it's gone up, down, up. In fact, this down here was due to the economic reforms of Mao Zedong, as he enacted, the changes he enacted resulted in the deaths of millions of people dying from famine and violence. And that was a significant drop, so that it showed up on a world population curve. But you can see overall the population growth rate is declining, and it's expected to continue in that way. But the population size is increasing. So the bottom line here is that overall, there's an overall increase in growth, but a decrease in, there's an overall increase in the number of people in the world, but a decrease in the growth rate. And the reason for that is that many developing countries still have large numbers of people in their reproductive years, young people. There is a new study now that indicates that population may grow till the end of this century and slightly beyond, which would be beyond 2100, and then stabilize at around 9 to 10 billion people. So if we go back for a minute to try to understand this increase in population size because of the number of young people, we can do this by looking at an age structure diagram. So these are very typical, and you'll notice that the y-axis, the x-axis, is the age group, and it's population in millions. So we've got 0 to 3 years old, 3, 6, 9, 12, 15. I'm sorry, let me say that again. This is the population in millions. So we have 0, 3 million, 6 million, 9 million, 12 million. And then the y-axis is the age group. So this is the 0 to 4. This next one is the 5 to 9, and so on. So on the right, you can see the females, and on the left, you can see the males. And this is for the U.S. in the year 2014. So these kinds of diagrams are really helpful in helping you predict the future population growth of a country. If you look at this diagram, what age group is most of the U.S. population in? If you look at this, is most of the U.S. population. Well, you might notice it is somewhere around here. And this would be ages 54 to 64. This is where we have most of our population. And these people are actually the baby boomers. The baby boomers were born between 1946 and 1964. 1946 was right after the war. There was a lot of, the economy went up, which resulted in more children being born. Well, these baby boomers are aging, so they're no longer reproducing, and they're going to be continuing to age, and as they do, they're going to have a big impact on the economy of the U.S. In any event, if we look here, the people who are of reproductive age are really down here. So you'll notice the U.S. has more of a top-heavy curve. There are more people who are beyond reproductive age than there are of productive age. If we go back to the baby boomers just for a minute, and why the age of a population can affect an economy. Well, look here, and you'll notice on the x-axis are years, starting with 2015, and the y-axis is Americans age 65 and older as a part of the population. And this actually comes from the U.S. Census Bureau. So you'll notice that the percent of people who are over 65 is expected to go up, and those people are expected to become a greater proportion of our population. In 2003, 82% of baby boomers were in the workforce, but by 2013, that had dropped to 66%. Here's another graph that shows you, again, on the x-axis is the age of the individuals, and the y-axis is the percent in the workforce. So the dark green line is the percent of baby boomers who are no longer in the workforce. And you can see it's increasing as their age increases. The light green line is the percent of baby boomers who are working full-time, part-time, or seeking work. And you can see this is going down. So what this is telling you is that the number of baby boomers not in the workforce is increasing, and the number of baby boomers who are working part-time or seeking work is decreasing. Which basically brings us to this point. Here we are again on the x-axis in years, and the y-axis is the projected U.S. population growth. So you can see that the total population growth is the blue line, and it's increasing very slowly. If you look at the red line, this is the percentage of individuals who are age 65 and up of the population. And so that's going up. The green line is the percentage of people 85 and up who are increasing. So the bottom line here is that there are going to be more people who are retired in the U.S. population as time goes by, and it's going to increase significantly. These retired people really make up the baby boomers. So what's the problem with that? Well, first of all, retired people don't produce anything. They don't contribute to the economy, at least directly. They also don't spend much money. They usually depend on others for support. And the fact that they're no longer in the workforce means fewer workers, because the population of young people coming up is less than the population of baby boomers. So this means there's going to be less economic growth, or that's what's being predicted. So again, you can see this is the share of the population age 65 and over, and now we're comparing other countries. So here's 2014 and here's 2015. So one thing you can see from this diagram is that all countries, at least in this diagram, all populations are aging in all countries. Which country has the most extreme aging? Well, you can see Japan currently has the most extreme aging, followed by Germany, France, and the UK. So a lot of Europe has an aging population as being a bigger part of their total population. And certainly by 2050, that is expected to increase quite a bit. You can see the U.S. is going up not quite as much as the other countries. So the impact of an aging population on the economy can be tremendous, especially if there are not younger people coming up to take their place, because there's no one contributing towards not just the workforce, but towards Social Security or something like that. In the U.S., the impact of the baby boomers leaving the workforce is not as severe as it could be due to immigration. So the people who are immigrating to the U.S. are building up our workforce, and so that will mitigate some of the impact on the economy, but that is not the case in Japan. Japan has a very strict immigration policy and doesn't let in a lot of immigrants, so they're starting to have a tough time. Let's take another look at what age structure diagrams can tell you. And on the left, we have Niger, which is a country in sub-Saharan Africa, and you can see they have kind of a pyramid-shaped curve. So what this curve is showing you, when you have this wide base, is that there are many people below 15 years old. And that means as they reach their reproductive years, they are going to reproduce. They're going to have more children. So in this kind of diagram, what you would expect is a big increase in population in the future. When you see these diagrams that are bottom heavy like that. So even if the females who are coming along only have 1 to 2 children, there's still going to be a big increase in the population because there's so many females of that age. On the other hand, here we can take a look at China's population, and you can see it's more, heavier, like kind of in the middle here, and these people are no longer producing. So you do have people at the bottom, and you do have a lot of people, but the population here is growing slowly. That's what we see in that kind of diagram. And interestingly enough, you'll notice, I don't know if you can notice, but there's more males. This is a symbol for males, and that's because of the one-child policy and the preference of people for male children. And there's also small groups in the lower age. So you would expect this population to grow slowly. Now here we have Japan, which is very top heavy, which means most people are older, and there's a small number of people in their reproductive years coming along the pipeline. Small number of people. More people are past their reproductive age. So for this population, you would expect a declining population. Okay, so the bottom line here is when you have a very large base, like you have in Niger, like a triangle, you would expect a rapidly growing population. When the middle is a little heavier, so you have more people in the middle-aged, past reproductive, but you still have a fair amount at the bottom, you would expect the population to grow slowly. When you have a top-heavy kind of curve, you would expect the population to decline because there are more people are dying than are being replaced. Here's another age structure diagram, and you can see they've kind of lumped developed countries and developing countries. And again, you see more of the triangle here with developing countries, and you can see that it's more top-heavy. So most of the increase in the world's population will be coming from these developing countries. So it does appear that the regions with youthful or very young populations are the fastest growing regions of the world. And if we look at this diagram, you can see that the red is the fastest growing and orange is the next fastest growing. And then of course the mature is the brown, transitional to the yellow. So according to this picture, where is most of the population growth expected in the future? Well, you can see it's in the continent of Africa. We can also see, India over here, and the Middle East is also a hotspot area. 99% of the next billion people added will be born in poor, less developed regions that are least able to support them. So what is going to be the impact on the environment from more people? And how do we predict this? Well, there's something called the IPAT model, which was developed based on what we have learned so far about growth. And it says that the total impact of humans on the environment is equal to three major factors. P is the population size. A is affluence. And affluence really is consumption rate. We know that the more money people have, the more resources they use. Now remember, we have said that all environmental problems in the world are really due to two factors: population size and consumption rate. So you can see them right here in the formula. There's a third one that we haven't really mentioned, which is technology. In general, the more technology, the more exploitation of resources, the greater the impact on the environment. So that is included here. S is a sensitivity factor, which just depends on what area of the world are you talking about and how sensitive is this to humans. Now this model is being further refined to include things like education, laws, and ethics, but it's pretty much a good way to view the impact that population has on the environment. And it is strongly driven by population size and consumption rate. China is a good example of how all the elements of the IPAT formula can combine to cause a tremendous environmental impact in a very small period of time. So consumption rate contributes towards the impact on the environment. And we have said that affluent societies have enormous resource consumption and waste. And the reason, in addition to this, they use resources from other areas as well as their own areas. So the ecological footprint of these developed countries is huge. In addition, the wealth gap and population growth contributes to violence and conflict. So one American, and this would be, Americans are people that are very affluent in general, has as much environmental impact as 6 Chinese or 12 Indians or Ethiopians. And that is showing you, again, the impact of affluence and consumption rate on the environment. Now remember, the carrying capacity of the Earth is limited. And in this particular diagram, you can see the years on the x-axis and the global footprint on the y-axis. And this is what some people predict the carrying capacity of the Earth. So some people predict or have calculated that the carrying capacity of the Earth is 1 billion humans. And it is based on the fact that with 1 billion people, everyone can live a prosperous life, and there's enough natural resources for everybody. And of course, we're at 7 billion now. So you can see that we have passed that point, and we passed it sometime in 1985. Other people say, well, the Earth can carry up to 33 billion people, but at that point there will be a degraded environment and everyone will be living in extreme poverty. So the bottom line is the Earth can't keep supporting our consuming lifestyle. This is a graph from the UN. And again, you can see on the x-axis the population growth, and then this is the projection for the future. World population is shown in blue, and the growth rate is shown in red. So again, you can see that our growth rate kind of peaked at 2.1%. This is the world. Sometime around the late 1970s, it peaked, and it's going down now, and it's going down fairly drastically. But the population will continue to increase, and that is again because some countries, some developing countries, have a very large base of young people. So even if those young people only have 1 or 2 children, they are still going to increase the population because there's so many of them. But then the population is expected to plateau out, and people predict anywhere from 9 to 10 billion. Here it shows 11 billion people. So what does that mean for the world? Well, this is showing us the carrying capacity of different regions of the world. And the y-axis is the hectares per person. So this is really the ecological footprint in a way. And the y-axis is showing you the countries. The orange is the ecological footprint, and the blue is the biocapacity, which means, so look at it this way. The orange is how many resources are used. The blue are how many resources are produced. So if we look at this graph, who uses more resources than they have? Well, simply look at where the blue is less than the orange. So Asia is one example, Europe, and North America. On the other hand, you can see that in Africa and Latin America and the Caribbean, they use less resources than they have. So this is something to keep in mind, because you would think that means, oh, well, then Africa and Latin America and the Caribbean, they're going to be fine. Even if their population increases, they still have plenty of resources. But keep in mind that these other countries are exceeding their own carrying capacity by taking resources from other countries and from other people. So in conclusion, human population now is larger than it has been at any time in the past, and populations are still increasing even though growth rates are down. Most developed countries have passed through the demographic transition, and most developing countries are well on their way. Not all, but most. Increased rights for women have resulted in decreased population growth, but remember that in order to achieve a sustainable world, we don't only have to decrease our population, we have to decrease our consumption rate. And that's something that's not happening yet. So here's an interesting figure from the magazine Nature. And what it's looking at is where can we put the next billion people on Earth? So if you look at the gray means unsuitable. So for example, Northern Africa is unsuitable, and that's mainly because it's desert, and the desert is increasing in capacity. Here's another area that is gray because there's a biodiversity there, and they don't want there to be greater human impact. Most of the southern U.S. and Mexico is considered unsuitable because of a lack of availability of water. The blue areas are considered somewhat suitable. So you'll notice that the blue areas are, up here in Russia. Now remember, this is still very, very cold up here. In Canada, northern Canada and Alaska, very, very cold. Here's an area that's somewhat suitable because we still have a lot of forest. And then you have areas that are considered very suitable, which is Central Africa, surprisingly enough, because they do have lots of natural resources. But again, the problem here is corrupt governments that make it difficult for people. Again, in South America, you seem to have a lot of area. Their moist tropical areas could support crops, which would be helpful. So just a kind of interesting thing to look at. I'm going to let you go through these questions yourself. It's a very good review of what we've covered.